Hello learners! I am Master Ryan. Welcome to Mathematics with Great Minds with Marivet Education Center. This series is for Prathom 6. We will learn about HCF and LCM word problems. Let's get started with our lesson. In this lesson, you'll be able to recall HCF and LCM through the given problems. You will be able to identify keywords and understand each problem through the given word situations. Can you still recall how to get the HCF and LCM of a given number? Let's find out. We will discuss word problems about HCF and LCM. The following word problems will be used for HCF solution. At a birthday party, there are 30 slices of pineapple and 42 slices of watermelon. John wants to put the slices of fruit equally on some plates. What is the greatest number of plates he will need to put the fruit slices? The keywords for this problem are greatest and equally. Now, what are the given numbers in the problem? We have 30 slices of pineapple and 42 slices of watermelon. What is being asked in the problem? The greatest number of plates John needs for his fruit slices. For us to find the greatest number of plates he needs, let's perform the short repeated division in getting the HCF of the problem. The given numbers again are 30 and 42. We need to find a common prime factor that can be divided to both numbers. Let's start with the smallest number, 2. Can we divide 2 to 30 and 42? That's right! 30 divided by 2 is 15, and 42 divided by 2 is 21. Now, can we still use 2 to divide 15 and 21? No, we can't. So let's proceed to the next common factor. We have 3. 15 divided by 3 is 5, and 21 divided by 3 is 7. We will stop since there is no more common factor to divide except 1. Next, let's multiply the divisors of 2 and 3. 2 times 3 is equal to 6. So, the HCF is 6, and 6 is the greatest number of plates John needs to equally divide his fruit slices. To check if 6 is the HCF of both numbers, let's use the factoring method. Factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. Factors of 42 are 1, 2, 3, 6, 7, 14, 21, and 42. Now, what is the highest common factor or HCF? Yes, 6 is their HCF. So our answer is correct. Let's have another problem. Let's read together. There are 16 pens and 8 pencils. Julian wants to put them equally into pencil cases with no pens or pencils left over. A. How many pencil cases are needed? B. How many pens and pencils go into each pencil case? What keyword can you see in the problem? Our keyword is equally. Now, the given numbers are 16 pens and 8 pencils. As we notice, there are 2 questions being asked in the problem. First, how many pencil cases are needed? Second, how many pens and pencils go into each pencil case? Let's try to solve it. Using repeated division, let's solve 16 and 8. Can you think of a common prime factor that we can divide with 16 and 8? Great! Let's start with 2. 16 divided by 2 is 8. 8 divided by 2 is 4. Now, can we still use 2 to divide 8 and 4? Yes! 8 divided by 2 is 4. And 4 divided by 2 is 2. We can again use 2 to divide 4 and 2. That would be 2 and 1. Because there is no common factor to divide with the quotient. Next, multiply the divisors. 2 times 2 times 2 is equal to 8. And that is our HCF, which answers the first question. So there are 8 pencil cases needed by Julian. How many pens and pencils can we put in each pencil case? We have 16 pens and 8 pencils. Let's divide it to 8. 16 divided by 8 is 2, and 8 divided by 8 is 1. Therefore, there will be 2 pens and 1 pencil in each pencil case. Did we answer the 2 questions? Brilliant learners! Next, we will use LCM to solve the following word problem. Let's read together. Cell phone A receives a message every 20 minutes. Cell phone B receives a message every 15 minutes. If both cell phones receive a message at 10 a.m., at what time would both cell phones receive the next message at the same time? The keyword for this problem is both. Now, what are the given numbers in the problem? We have 20 minutes for cell phone A and 15 minutes for cell phone B. What is being asked in the problem? What time would both cell phones receive the next message at the same time? Do you remember how to get the LCM of given numbers? We can also use repeated division method for this. The given numbers again are 20 minutes for cell phone A and 15 minutes for cell phone B. Now, let's put the 2 numbers below, 20 and 15. Divide starting with smallest prime number, then stop when all quotients are 1. Let's start with 2. So, 20 divided by 2, that would be 10. And just bring down 15. Let's divide it by 2 again. 10 divided by 2 is 5. Just bring down 15 again since it can't be divided into 2. Let's divide them now with 3. Bring down 5 because it can't be divided by 3. Proceed to the next. 15 divided by 3 is 5. Let's divide the remaining quotient by 5, and that would give us a quotient of 1, and we stop. Next step would be multiplying all divisors at the left column. 2 times 2 times 3 times 5 is equal to 60. Thus, both cell phones will receive a message at the same time in 60 minutes or in an hour. Do we have the same answer? Fantastic! Let's have another one. Let's read together. Ben and Joyce baked the same number of muffins. They each baked fewer than 50 muffins. Ben packed 9 muffins in each box without any left over. Joyce packed 12 muffins in each box without any left over. How many muffins did each of them bake? What keywords can you read in the problem? We have fewer and left over. Now, the given numbers are 9 muffins packed by Ben and 12 muffins packed by Joyce. What is being asked in the problem? How many muffins did each of them bake? Let's solve the problem. Then, we stop when all quotients are 1. Let's use 3 to start our division. 9 divided by 3 is 3. 12 divided by 3 is 4. To make the quotient into 1, let's divide it with the same number. 3 divided by 3 is 1. Bring down 4. Let's divide with 4. Bring down 1. 4 divided by 4 is 1. Then we stop. Multiply the divisors. 3 times 3 times 4 is equal to 36. Therefore, each of them baked 36 muffins. Let's try the following problems. The table below shows the number of adults and children at a concert. The seating arrangement is to have an equal number of people in each row, and each row will only have adults, boys or girls. What is the greatest number of people who can sit in each row? There are 64 adults, 48 boys, and 56 girls. What is asked in the problem? Correct! And what is our keyword or words for this? Right! Greatest and equal are the keywords, which means we are asked to find the HCF of the problem in order to equally divide the people who will be sitting on each row. Now let's solve. 64, 48, and 56. What common prime factor can we divide for these numbers? Remember to start with the smallest common prime factor. Great! Let's have 2. 64 divided by 2 is 32. 48 divided by 2 is 24. 56 divided by 2 is 28. Can we still divide it by 2? 32 divided by 2 is 16. 24 divided by 2 is 12. 28 divided by 2 is 14. What common prime factor can we still use to divide next? We can still use 2. 16 divided by 2 is 8. 12 divided by 2 is 6. 14 divided by 2 is 7. So we stop from here since there is no common prime factor that we can divide except 1. Then what's next? Yes, we will multiply all the divisors. 2 times 2 times 2 is equal to 8. Good job! Therefore, 8 is the greatest number of people who can sit in each row. Brilliant learners! Now let's have the last one. Let's read together. Peyton wants a ribbon which can be cut equally into either 12 centimeters, 24 centimeters, or 32 centimeters with no left over. What can be the shortest length of the ribbon she wants? What is being asked in the problem? Right! We are asked to find the shortest length of the ribbon that Peyton wants. What is our keyword or words for this? Great! Left over and shortest length, which means we are asked to find the LCM of the problem in order to know equally the shortest length of the ribbon with no left over. Let's start solving. The given numbers in the problem are 12 centimeters, 24 centimeters, and 32 centimeters. Now, think of a smallest prime number that we can divide with these numbers. Let's have 2. 12 divided by 2 is, good job, 6. 24 divided by 2 is, great, 12. 32 divided by 2 is, Excellent, 16. Next, can we still divide it by 2? You're right. 6 divided by 2 is exactly 3. 12 divided by 2 is 6. 16 divided by 2 is 8. Next, what prime number can we still use to divide? 3. 3 divided by 3 is 1. 6 divided by 3 is 2. And we bring down 8 since we can't divide it to 3. What prime number can we divide next? We can use again 2. We bring down 1, start with the next number. 2 divided by 2 is 1. 8 divided by 2 is 4. Good! To make all quotient to 1, what number can we divide from these numbers? Wonderful! 4. Bring down 1 and 1, and let's proceed with 4. 4 divided by 4 is 1, and we stop. Then, let's multiply all divisors. 2 times 2 times 3 times 2 times 4 is equal to 96. Therefore, the shortest length of ribbon Peyton wants is 96 centimeters. Great job, learners! To summarize our lesson, here are the things that you need to remember. In order to solve word problems for HCF and LCM, first, remember the keyword or words. For HCF, largest, greatest, each, equally or equal, and longest. For LCM, leftover, fewer, both, shortest, all, and least. Lastly, in solving HCF, start with the smallest common factor until there is no more common factor to divide except 1. The same goes with LCM. Start with the smallest prime number and stop when all quotients are 1. Then multiply all divisors to get the final answer. That's all for our HCF and LCM word problems. Hope you had fun learning. See you in the next episodes.